Hey guys, welcome back. So I'm just going to continue our discussion on quadratic functions. So second topic in your notes is called the standard form of a quadratic function. So just if you remember way back to Math 10C, we had a unit called linear functions. Okay, and so it's in linear functions we had we talked about one form of a linear function, which was like y equals mx plus b. Okay, so this was like called slope-intercept form. Another form was ax plus by plus c equals 0. Okay, so this guy was in what we called slope-intercept. This was what we called general form. Okay, so yeah, we had kind of two different forms of linear functions. Now back to quadratics, we have several ways that we can represent quadratic functions. Okay, the way we learned about it in the previous lesson was called the vertex form of a quadratic function. Now that's very nice. I'd say vertex form is very nice because like you can kind of pick off immediately where the vertex is, and you can see the direction of the opening to quadratic, and you can kind of graph it easier. I said the standard form is definitely not quite as nice because it's harder to be able to determine what the vertex is, but we still need to get kind of good at practicing how to do this form of quadratic function. All right, so just a quick review. Determine the equation of the quadratic function that has a vertex of 5, 4 and passes through 3, negative 4. Okay, so just quick sketch of this guy, 5, 4. We'll say it's right here. And then 3, negative 4, which is the left of here, and then down over here. So 3, negative 4, and the graph would look like this. And that's 3, negative 4. Okay, so the way we did this was, this was our PQ, and this was our XY. And the vertex form of a quadratic is y equals a x minus p squared plus q. This is on your formula sheet, guys. You do not need to have it memorized. You will, because you've been doing so many of these questions in this unit like that. You will have it memorized, but it's on your formula sheet. Okay. Now we're just going to start plugging the values. Negative 4 is y. We do not know a is what we're looking for. X is 3. P is 5. Q is 4. I'm going to subtract 4 from both sides. I get negative 8 equals a. 3 minus 5 is negative 2. Squared is 4. Divide by 4. Negative 2 equals a. So we get y equals negative 2. X minus 5 squared plus 4. Okay, so this is how we did questions like this. This is the vertex form of the quadratic functions review from our last lesson. All right, other review we have to do over here. So we have to expand and put in brackets, distribute, multiply, FOIL. All of these mean really the same thing in this unit. Okay. Now the thing we have to remember that x plus 1 squared does not equal x squared plus 1 squared. Okay, so it's not equal to this. If I see x plus 1 squared, what it equals is x plus 1 times x plus 1. Okay, so we need to be able to use the distributive property to be able to multiply this through. Okay, now your Math 10 teacher may have taught you distributive property. They may have said just multiply it. They may have said FOIL. Okay, now FOIL stands for first, outside, inside, last, which is an acronym that we use to be able to multiply this. But what it means is like that this x here has to be multiplied to both terms in this set of brackets, and this 1 has to be multiplied to both terms over here as well. So when we do that, we get x squared. That's this. X times x is x squared. X times 1 is positive x. 1 times x is positive x. 1 times 1 is 1. So we get x squared plus 2x plus 1. The second one, same idea. This is x minus 5 times x minus 5 equals x squared minus 5x minus 5x. Negative 5 times negative 5 is positive 25. And we get x squared minus 10x plus 25. Okay, I'm just going to do this work over here because I have a bit more room. If you hear that screaming in the background, it's my 2-year-old running around just getting in trouble right now, having the time of her life right now during quarantine. But all right, so what this is here is 5, x minus 6, x minus 6. Now, a couple ways I could do this. I'm just going to multiply these guys first. I can keep this 5 here, and I'm just going to multiply these guys. So it's going to be x squared minus 6x minus 6x plus 36. all right, equals 5x squared minus 30x minus 30x plus 180. 5 times 36 is 180. So cleaning this out up a bit is 5x squared minus 60x plus 180. Okay, perfect. So last one, negative 3 times x plus 2 squared. That's negative 3 times x plus 2 times x plus 2 equals negative 3. And I'm just going to multiply these guys together. X squared plus 2x plus 2x plus 4. And now I'm going to multiply the negative 3 through the brackets here, and we get negative 3x squared minus 6x minus 6x minus 12. All right, so there's our right. So here's how we've been able to just kind of practice up on how we expand each of these polynomials over here. Okay, so this is kind of a review from Math 10C as well. All right, so two ways of writing a quadratic function. We have the vertex form, which is in the form y equals a x minus p squared plus q. Standard form is going to be y equals ax squared plus bx plus c. Okay, I'm going to show you in a second. So there's a way how these guys are going to be equivalent. We're going to show you how those guys are equivalent in a moment here. All right. So on your calculator, first of all, guys, these equations over here, this one and this one, they don't look the same. Okay, they're different. But if this is an example in vertex form, and this is an example in standard form. Okay, and I'm going to show you in a second that they actually are the same thing. So I'm going to show you on your guys' graphing calculators over here. Never mind, I'm going to show you on Desmos how to do this one. All right, so we have y equals x minus 3 squared. I think that's plus. Sorry, guys, forgot what my function was here. Minus 2. All right, so we have this one, like we saw in our last topic. The vertex is translated 3 to the right and then down 2. So we have 3, negative 2 as our vertex. And this guy has a positive out in front, so we know it's opening to the right. So better, how we get to each point. If I go 1 to the right, 1 squared is 1. If I go 2 to the right, 2 squared is 4. I'm going 1, 2, 3, 4 up over here. If I go 1, 2, 3 to the right, 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is this point over here. Same thing going to the left. Negative 1 squared is 1. I'm going up 1. Negative 2 squared is 4. I'm going up 4. From here, negative 3 squared is 9. I'm going up 9 to get to this point over here. Okay, so that's how this one works. Now the idea is, my second one, in standard form, we're going to be getting the exact same graph over here. So here you can see that the red graph and the blue graph are overlapping each other. Okay, so they're actually the exact same graph over here. Although they look very different, this is in vertex form, this is in standard form. Okay, so these are kind of the two different forms of the same quadratic function over here. Okay. So vertex form, and this is standard form. And I'm just going to say that both represent the same quadratic function. All right, both represent the same quadratic function. All right, okay. So example 4 says convert to standard form. Okay, so if I have y equals x minus 2 squared plus 7, I want to convert this into this form over here. Now, what we want to do is, like we practiced in the previous example, we want to expand or fold or distribute this term over here. Okay, so y equals this x minus 2, x minus 2. Now this plus 7 is not part of this multiplication over here. So we're going to multiply these two together and then add this 7 afterwards. This is going to be x squared minus 2x minus 2x. Negative 2 times negative 2 is plus 4 plus 7. Y equals x squared minus 4x plus 11. Okay, so this is the equation in standard form. Here's the equation in vertex form. Okay, same idea over here. We are going to expand this. We're going to keep the negative 2 out in front for the moment, and keep the 12 separate for the moment as well. So negative 2, x plus 4, x plus 4, that's how the squared works, plus 12. So we got y equals negative 2, x squared plus 4x plus 4x plus 16 plus 12. Now I'm going to multiply this negative 2 through. Now the negative 2 is applied to everything inside the brackets. It is not being applied to this 12 because this 12 is still separate. So we get negative 2x squared minus 8x minus 8x, and it's coming from negative 2 times this times this times this. 16 times negative 2 is negative 32. Now I still have the plus 12 separate here. Y equals negative 2x squared minus 16x. Negative 32 plus 12 is negative 20. Okay. All right, determine the vertex without using a graphing calculator. Okay, guys, I'm not going to. I was having a problem with my graphing calculator software. I'm just going to pause the video here for a second, and then I'll just make a second video for this last example here.